I'm a student at Berkeley.
So today we're going to be showing you how to make a very simple Python game. This is kind of designed for I'm kind of assuming that you don't really have very much programming experience, or you don't really have that much Python experience. If you do have some coding experience, it'll probably feel a little bit slow. That's just all I say. And I think Ajay will show you the game we're going to be making.
Oh, kind of ended prematurely.
So you have to.
Oh yeah, so basically you're the doctor and you're trying to dodge the coronavirus. It's a simple game, but I'm sure you guys will learn a lot from it.
So we're using, I think the easiest way to approach this for us is, right now we're using this online IDE called Replit. Ajay, you should put the link in the chat.
Yeah, I'll put the link in the chat.
This way we won't have to go through the installation, because that can sort of be a little bit tricky depending what operating system you're on. Yeah, and I'll give you guys a minute or so to sign up.
Is the link in the chat?
Sorry,
or?
I accidentally DM'd it to Todd. Here's the link.
All right. Any of you guys not done with that? All right.
I'm in.
All right. Okay. I guess I'll just get started. We're just going to first we just want to go over some basic Python. If you've never programmed in Python, or if you don't even know how to program, this will be really helpful. We'll go over this kind of quickly. So first of all, sort of basic thing in Python is assigning variables. So here we're saying x equals 3. And if you've programmed in other languages, this should be pretty familiar. So we say x equals 3 and print x, x is storing the value of 3. So when we print x, it prints 3. And if we want to say like something like print, sorry, x plus 1 or print x times 2, this is the operator for times, then it will give us 4 and 6. Pretty logical. We also go over like the sort of types that we're going to be needing to use for in order to make this game. So this 3 right here, it's an integer. So that just means that it's like a number. It means that it's like kind of there to do math. If you put quotation marks like surrounding something like this, then this will create a string. And this means that it's like, it means that it's like English. It's like a word. So if we try to run this, this won't work because this is a string and this is an integer. These two types, you can't add them together. So if we instead do something like print x, get rid of that, +1, it'll print hello world in the console. Although this does not work, you can do something like this, turn that one into a string. And this is like, oh, sorry. So this is more like, you can think of this one as like sort of like a 1 in like English class. It's not like meant for math. It's meant for like to be part of like a sentence, or it's like a character. Okay, so that was integers and strings. Python has another type called a tuple. If you guys have seen an array before, it's very similar. So like the only difference between this and an array is that in a tuple, the values are not mutable, they're not changeable. So a tuple is like a list of numbers. We can do that. It's you surround it with parentheses and it's separated by commas. So this is a tuple, and we can just print it out, and you can see we just get a list of numbers. If you want to access like a number in, like if you want to access something inside the tuple, let's say I want to access this first element, then we use square brackets, and we'll say what index it is. And if you've programmed in other languages, you'll be familiar with the fact that like it's usually most languages are 0 indexed. So in order to access this first element, then we'll say like, we'll put a 0 here. And this means that we're going to be accessing the first element of the tuple. So if we run that, it'll print out the 1 because we just accessed the first element of the tuple. Okay. Finally, the other type we'll need to know are Booleans. Simply put, they're true or false. So I can do something like x equals true, print x, oops, print x. Then it prints true. You can do a little bit more advanced things with this though, because you can sort of use this to do logic in Python. So for example, let's say we want to see if x is greater, it's like a positive number. So we can say print x greater than 0. And if we run this, it prints true. So this is like a comparator operator. It checks, if x is greater than this right side. And because it is greater than the right side, this evaluates to true, and it's going to print that out. Alternatively, if we did, less than, if we say print x less than 0, that'll print false because 1 is not less than 0. The other important comparator operators are less than or equal to. So like you can evaluate if x is less than or equal to 0. We run that, it's still false, but if x is 0, we run this, it's true because 0 is less than or equal to 0. You can also do greater than or equal to 0. If you want to check for equality, you just say like x equals 0. This double equals sign is checking for equality. So in this case, it's saying this is basically asking, is 0 equal to 0? And because 0 is equal to 0, if we run this, it'll print true. Alternatively, if we want to check if it's not equal to, we just use an exclamation mark equal. And So we run this. This is false because it is equal to 0. So this not equal to it doesn't work. But if we say like x equals 1 and we run this, then it evaluates to true. Another quick thing is that if you want to type some comments in Python, you just be like, you use the hashtag. So this is a comment, and it will not evaluate when you run the code. I think Ajay will explain some control flow in order to do logic in Python.
Thank you. So now that we know some of the basic data types, we can put it together using control. So one of the control allows you to choose what statements you want to run and what statements you want to skip. So one of the most basic control statements is the if statement. So the structure is like if condition, then we have a statement to run. So if this condition is true, then we run this statement. And this condition always has to evaluate to a Boolean, so either true or false. For example, we can have statement is 4 greater than 3, which is true. Then we can print 4 is greater than 3. And this should print 4 is greater than 3. However, let's say we change this to 2. It won't print anything. Say we want to do something else. Instead of if this part isn't true, we can attach an else statement. So this is like, if this isn't true, go down and automatically run this, and maybe we can print 2 is less than 3, and this should print like that. So there's the if statement, there's the else statement. There's also statements we can run in between called the elif statement. So if this isn't true, then we can run another, we can check for this whatever condition we have here, and say like this condition is 2 equals 2, print. So now we should expect this to print, because although this isn't true, this will evaluate to true and this would print. And then it skips this else statement, because only one, if we have it, if, elif, else chain, like only one of them will print. And it goes from top to bottom, always checks them in order. So even if I put something like elif true here, which will always evaluate to true, and I say print here, this won't run at all. So you have to keep that in mind whenever you're coding. Another type of control statement is the loop. So the loop allows us to repeat code till a condition is met, or for some like certain amount of time. So we can loop one piece of code exactly 10 times if we need to, or 100 times. We just need to define it. So one of the loops is called the while loop. So the while loop is while, and then we have a condition, and then we have code here. And basically all the code indented. So Python uses indents to parse code. So all the code indented. So like if I have code here that's indented, but then I don't have code here that's indented, this code gets looped, but this code won't get looped for this condition. And a condition also evaluates to a Boolean. So we can have maybe, let's do a counter. So let's have count equals 0. You can say while count is less than 10. And we can increment count with assignment. So this will take the value of count, the previous value, and it'll evaluate to 1, and set that equal to count. And then it'll loop again because count is 1. And then we have 1 here plus 1. We get count equals 2. It'll loop again. It'll keep on doing that until we get to 11, because or 10, because 10 isn't less than 10. and then I can print out the value of count. And we get it all the way up to 10. So you can, in our game, you'll see that we actually use a while loop to loop through the frames of the game, because each frame, like it's like a movie, like where you have each frame is like a picture, but it's a game. In the game, you have different frames. And we'll just loop through it, and then when the game is over, we'll have a condition to check that, and the game will end, and the while loop, it'll exit the while loop. So another type of loop is the for loop. So the for loop allows us to iterate through data types called iterables. One iterable we went over was the tuple, but there's also the list, which, and I guess I'll show you an example with the tuple, since that's the one we worked with. Say we have a tuple like this. So we can, the for statement works like this. We can have for I in X, print I. So basically, for every element I in the tuple X, we'll print that out. So we should get 1, 2, 3, 4, 5, and we can change this, say, to 90, and should print 90 there. So you just want to loop like 10 times, like a specific number amount of times. You can also use what is called range, which returns the iterable from 0 to whatever you input. So you can see here, int is stop. That's the int, which is stop, and it doesn't include that. So it's not inclusive. So if I did 10 here, it would go from 0, 1, 2, 3, 4 all the way up to 9. It doesn't include 10. So for I. If we run this, it should print. Is it lagging? Oh, okay, yeah. So it should print from 0 to 9. So yeah, we're also going to be using the for loop. So we'll be looping through every event, which is basically what the user's doing. So like any mouse clicks, any arrow key button clicks, or the mouse position. We'll look at that more as we start to look at the Pygame package. So Todd, do you want to start doing Pygame?
Yeah, sure. But before I go on, does anyone have any questions?
Oh yeah.
Okay, I guess I'll just get started. Okay, for this. All right, so yeah, we'll just get started with making this game. The first thing you want to do is just say import Pygame. So this is how you import a library in Python, and Pygame essentially handles it handles a lot of stuff that some other people have coded, and we could just use their functions. So we don't need to know how to make a screen appear, because Pygame will let us. They already have provided that for us. So we can just use import Pygame, and then we'll be able to use Pygame's functions. And the first thing we want to do is just use pygame.init, and this will basically initialize the game. Oh, whoops, that's annoying. All right. Okay, and then what we're going to want to do is define some variables. We're first going to create variables for the dimensions of the screen, and we're just going to call it display width, and we're going to set it to 800, and display height equal to 600. And okay, so right now it's not affecting the game, but we're going to be using this in some functions. and you'll see it affects the screen somehow. We're also going to be using, we're also going to define some variables for colors so that we can also put into Pygame's functions. I don't know if the last person went over RGB, but so if you don't know what RGB is, basically most computers, they display like a color using some combination of red, green, and blue. So in Python or in Pygame, it'll usually be displayed as, it'll usually be like represented as a tuple of 3 different numbers. So black will be three zeros. So this is what you like pass into a function to create black. And then white will be this. So it's sort of like the combination of all colors of red, green, and blue together. It's 255 for like some reason about binary. It's not very important. Then we'll say red, because red is the first, like it's the first color in RGB, right? Red, green, blue. We're going to put 255 on the first one, and this will give us red. And then we're just going to set 0 to green and blue. And then likewise, if we want to do green in RGB, green is the second one, 255, 0, and blue equals, blue's the last one. So, all right. So we created these in order to make it easier for us in like later Pygame functions to just say like, oh, we want blue, and we don't have to like write this tuple again. All right. Okay. So then after we got these variables done, we'll want to create the screen, the display. So we're going to create a variable called game_display, and this will be pygame.display.set_mode. So this function will, like, when we run it, it'll create like the window for the game, and it takes in a parameter that tells you the dimensions of the screen. So this is where this display width and display height are useful. So this takes in a tuple of just the x and the y, the width and the height. So it would look something like this. But luckily we've already defined these here, so we can just use that. So we'll use display width and display height. So we're using a tuple in here as one of the parameters for the display, and this will mean that when we run the game, it should be 800 by 600. We're also going to want to do this pygame.display.set_caption, and then we'll say my game. This just does the caption of the window. I don't think this is that important, but it's good to have. And so basically when you run the game, the caption will just say my game. And then finally, we're going to create a clock. And to do that, we use clock equals pygame.time.clock. This makes it so that you can control the frame rate, so that you can like make the while loop go at a controllable rate. Otherwise, it kind of just runs at like a maximum speed, and that can create some problems. If some of this is like confusing, or if it's confusing, then don't worry about it. Like, try to follow along this. You'll see how it gets implemented. Okay, so now let's go over the game loop, as Ajay was mentioning earlier. So in order to make a game loop, we'll need to do like a while loop, and we're going to have some condition. Because we want the game loop to just like start right off the bat, we're just going to define a variable, a Boolean variable, and just set it to true. So we'll say running equals true. And then we'll just say while running, and then we're going to have the beef of the game inside this while loop. And the reason why we don't just say like while true is because in order to sort of exit the loop to be done in the game, we're going to set like running equals false. And I can do that right now, actually. So Actually, I'll get into that in a little bit, because first we have to go over like what events are. So right now, like this game, there's a game loop, but we need to be able to like exit the game. So in order to do that, we're going to have to use events, and we're going to have to use like a for loop. So so what you're going to have to type in is for event in pygame.event.get. So as Ajay mentioned, this basically, this pygame.event.get function, it basically keeps track of everything the user does. So like it keeps track of where the mouse is. It keeps track of what buttons are being pressed. Yeah, so this is how you sort of have like, like if you want to like move something in a game, you're going to use this. And this for loop is iterating over every event. So it's tracking all events. And then in order to determine like what event is being activated, like is he or she, or are they moving, are they pressing like the arrow key, right? Or are they pressing the X button? So in order for us to do that, we'll have if event.type equals pygame.quit. And it is case sensitive. And then we'll say running equals false. So what this does is basically this allows you to quit the game. So while the window is showing up, if you press the X button, it'll set this running equal to false, and it'll stop running the game. And finally, one last component is we're going to have, I think it's pygame.quit. Yes, pygame.quit. Okay, so this makes it so that if you press the X button, if you press that quit button on the top right of the corner, it'll set running to false, and then it'll exit this while loop. And then it will run this last code, and what's running the code will realize that the game is done and then quit the game. And then finally, one last thing we need to do is set the display so you can actually like see the screen. In order to do that, we're going to use that variable we defined here, game display. And we're going to say, and you want to put this on the first indent, so like on this indent. So that, because you don't want it to be a part of this for loop, but you want it to be a part of this while loop over here. So we'll write game display, and then we're going to fill it with a color. So let's just use black as the background. So we have game display.fill, and then we're passing in this tuple we created earlier, black. And this will make it so that the background of the game, of the window, will be black. And then two more lines we need. We just need pygame.display.update. And this just updates the screen. You just kind of need it to tell the screen to display what you've told it to display. And then we're just going to put clock.tick 60. And this will just control the frame rate. It makes it so the while loop has to pause for 60 ticks. It's not necessarily essential, but it's good to have this. And if we run this now, yeah, as you can see, we have a screen. It's not very impressive, but we've got like the sort of the foundation done now. And we should, and now we can leave it too. So that's good. Ajay, you want to explain the next stuff?
Sure. So now that we have a screen, it's a little lonely, so we should probably add a player to it. So we're going to start by teaching you how to draw a rectangle on the screen. So before we do that, we should probably define some variables. So this rectangle is going to be our player. So, and every rectangle has a width and a height. So we'll define that as the player width and the player height. For now, I'm just making it 160. You can choose whatever value you want, but keep in mind that our display is 800 and 600, so don't make it bigger than that. And also the player is going to have it, or the player or the rectangle, they're the same thing. It's going to have an X and Y position. So for now, we're just going to try to define it so it's at the center of the screen. So we'll just multiply it by the display width by 0.5 and display height by 0.5 to get the center of the screen. Okay, now that we have these variables, we can go on to drawing the player. So make sure you do it after you fill the game display black. So it draws it on top of the game display. So we'll be accessing the variable from the function from the Pygame package. So pygame.draw.rect. And you can do other shapes, but we're going to use a rectangle because it makes collisions easy. So we've taken the surface, which is the game display, and then the color. So I'll just pick green, which we define above in the tuple. And finally, we need to do a new tuple where we're inside the function where we define the width and the height. Sorry. We define the X and Y position and then the width and height. So player X, player Y, player width, player height. And that's all we should need to display the rectangle. I'll make the screen bigger. One thing that I noticed though is our rectangle, it's not centered in the screen. It looks like only this point is centered. And that's one thing we need to be careful about. So the position of the rectangle is not from the center of the rectangle, but the upper left corner. So we have to take into account this offset whenever we're checking the position of the rectangle, say if it goes out of boundaries or we want to do collision. So what we have to do to take into account this offset is before we cut it in half, the true range of this rectangle is only going to be from 0 to display width minus the rectangle's width. So because you can't go, the rectangle is going to hit before I think it reloaded, before it's going to hit the wall if we're measuring from here. So that's why we're going to subtract that offset. And then we can extend the same logic for the player height. And so this should center our rectangle. So yeah, there we go. So now the rectangle is centered, and we can using this we can control the position. So when you saw the game demo, the rectangle is actually at the bottom of the screen. So we should probably multiply this by 0.9. And the reason is, so this is 0. This point here is 0, 0. So that means as we increase the Y position, we're going to go down, and as we increase the X position, we're going to go right. So we're going to multiply by 0.9, and this should give us the square a little bit closer to the bottom, which is ideal. So now that we have a rectangle, we should try to start moving it so we can play the game. So to do that, we need to utilize this this variable called event, and I guess I think it's important that I show you what the event is. It's basically a variable that where you can access the player's position, their button keystrokes. So I'm going to print it out and we can see it in the console. So you can see below the mouse position. This is going to be the mouse position. And then you can see it also gives us button information, window information, and I'm going to click some keys. So, oh wait, I'm going to click some keys, and now you can see key down, key up. So key down means I'm pressing a key down. It doesn't mean I'm pressing the arrow key down, like the arrow key down. It can be any key. So if I press the key O, it'll track. Oh, that tracks as a text input. But so basically, key down means I'm pressing some key down, and key up means I release my finger, and that's going to be important when we're doing movement. So if we want to move the player, we need to define some more variables. So we want to give the player a speed. For now, it's just I'm just going to set it equal to 5. You can make the player faster or slower based on how difficult the game you want to make the game. And then another variable which helps us change the player's location is it's going to be X change. So we're going to be adding this to the player X every time we loop. So that way player X will equal player X plus X change. And there is a shorthand for this. So if you don't want to have to write it like this, you can do plus equals. But I'll leave both. Okay, so this variable we're going to be changing. So if we're pressing the left arrow key, we want to make X change negative speed. So we're adding -5 to the position each time while we have the key down. And if we want it, we're moving to the right, we want to make it positive speed. So first we're going to check if the event type equals, Pygame.key down. So that's if we're pressing a key down. And then we want to get the specific key. So there is definition for key left, which we're going to set X change equal to negative player speed. And then there's the other event where we click the right arrow key. So that's going to be key right. We're going to set X change just to player speeds because we want to be adding the player speed. So let's try running this and see how it goes. So now I can click the arrow keys, but there is a problem. When I release my finger, the box is still moving. So that's a bug we have to fix. And the reason is we're only checking if the key is down. Like once the key is down, we set X change equal to negative speed, and it's just going to continue to move to the left. So what we want to do is when the player has their key up, we want and we have to check the specific key because it can be any key up. If it has the left or the right key up, then we want to set X change equal to 0. So we're going to use what is called the OR operator. In logic, OR means if one of this thing is true or if another thing is true, then it's true. So true or false is true, false or true is true, true or true is true, and then false or false is false. So now that we've checked that, if we move it and we release our key, it stops. And this is because we're checking if the key's up. And then in that if statement, we're checking if the key is left or key is right. So like meaning we put one of those keys up, not some random key like Y or W, but the left and right key. And I guess one last thing we should probably fix is the bot. You can cheat the game by leaving the screen. So we should check if the box is leaving and set running equal to false to end the game. So what we can do is after we update the player's location, we can check if player X is less than 0 or player X plus, we have to add the player width because we have to count for the offset, is greater than game display width, sorry. Then we want to set running equal to false. And that should end the game if we leave either sides. Just to be certain, I will check the right side too. So that looks good. Now that we have that, we need to set up the enemy. So the enemy will be, as you saw in the demo, the enemy will be raining from the sky. So what it does is it'll come and it'll go down, and then once it hits the bottom, we'll detect that, and then we'll have it respawn in a random location above. So we're gonna utilize the random package of the Python to generate the random like position it spawns at the top of the screen to make the game a little bit harder. So the enemy will have its own width. So because we'll be using a rectangle. And we'll just make it half. But feel free to change it to whatever you want to make the game easier or harder. So this is where we'll be utilizing the randomness. So since it's random's another package, we'll use the dot operator, and we'll be utilizing random int. So random int gets a random integer from the range 0 to b, and I don't think it includes b. So what we want is we want a random integer from 0 to display width minus enemy width, because we have to take into account the offset, and then the enemy y can just be 0, and then the enemy will also have a speed. We can make that 6 or anything you want. So now we have these variables. We can draw the enemy, and it should be very much the same as our player, but we'll change the color, and then we do have to change these variables to be enemy. So every player is just going to be enemy. Okay, this should display the enemy rectangle. So if I run this again, it'll be in a different location because it uses randomness. See, and I can run it multiple times, and it's hard to predict where it would be, but we know it'll be in between these two, the 0 and display width minus the enemy width, because that's how we define it. So it'll always be on the screen. Finally, we should update the location of the enemy. So we'll be using control statement and if else logic again. So we'll first check if the enemy y is greater than enemy y plus the enemy height is greater than the display height. Because you have to take into account the offset. And if that is the case, then the enemy y will reset that to the top of the screen. So that means it reached the bottom of the screen. So we'll set that equal to 0. And then we have to generate a new x location. So we'll do the same random function. Otherwise, we just want to increment the y position of the enemy because we're going to be having it fall from the screen. So we can use the plus equals operator and then the enemy speed. So now the enemy should be raining from the sky. And once it hits the screen, it goes to a new random location again. And it should stay here, but so yeah, it looks like it has the desired behavior. So next, Todd will show you how to deal with collisions because currently there's really no way to end the game unless you leave the screen.
Okay, yeah. So as Ajay said, we're going to want to basically check if the green box and the red box are touching each other. In order to do this, let's see. So I'll put it here. We're going to do something similar where if the boxes collide, we'll set running to false. So first, we will want to check like the way we're going to be doing this is we're going to check if they're in the same column, and then we're going to check if they're like in the same like row. So first, we're going to like compare x's, and if the green box is like touching the red box, x, y's will set running to false. So in order to do that, we're going to say if player, let's see, player x is less than enemy width plus enemy x. So this first part is checking if this player x, it's the x coordinate of the player box. So it's the left side of the player box. And then this enemy width and this enemy x right here is the it's the left side of the enemy box, and then we're adding this width, so that takes us to like the right side of that box. Ajay, is enemy? Why is it red? Oh, okay, I think that's not an issue.
I think it's fine. Sometimes
okay.
Just...
So basically, this is just checking because this is a less than. It's checking if the left side of the player box, the green box, is to the left of the right side of the enemy box. Obviously, that's not enough. So we need to add the sort of other condition. We're going to say and then player x is greater than player x plus player width is greater than enemy x. All right, so and then let's say running equals false, and then let's just see what happens here. We run this. It might be kind of weird. Yeah, so as you see, you might have saw that red box like showed up right on top of the green box and the game just stopped. So basically what, like this math might be a little bit confusing. If it's confusing, don't worry about it. You just think through it later. But basically what this is doing is it's checking if like the box is colliding in the same column, if it's in the same column as the red box. And then the nice thing about it is like if you get this, or even if you don't get it, this this same logic can be applied to the sort of row wise. So the y, the sort of y aspect. So we can just copy and paste this here. And all we have to do is replace x with y and then replace width with height. So let's do that very quick. And then now set running equals false. And now if we, so because this logic, it's like the exact same as like the logic with the columns, but we're just applying it to rows. If we run this, it should be a like sort of, well, as you can see, when it collided, the game stopped. So it's should work as like a fully fledged game now. So yeah, so hopefully you've been able to follow along this whole time, because that's basically a lot of the content of the game. Ajay I think he wants to show how to like put an image onto those boxes, but that handles most of the logic of the game. And yeah, so that's how you make a very simple game.
Oh yeah, so I can quickly add a little bit. Doesn't take too many lines of code to add an image to the game. 1 second. Okay, so we can define a new variable up here that loads in the image. So I have 2 PNGs that we'll use for the game, and they're the same size as the rectangles we're going to be using. So we can load in the doctor image using this Pygame function. So we just need to provide the name of the image, or if you have it in folders, you can provide the image path. So looks like I named it doctor. And we can also do the same for this. So now that we've loaded in the image, in case your image is a different size, you do want to get the width and the height of the image. So what you can do is this variable contains the information. We can use a dot operator to get it. So we can get the rect that represents the image, and every rectangle has a size. And kind of the way it's structured is it's a tuple with the width and the height. So we can 0 index the width, and then for for 1, if we put 1 here, we'll get the height. So we can just copy this and just change that to 1. And then same thing applies to the enemy. Change the image. Finally, instead of drawing a rectangle, we're going to be drawing an image. So we can comment out this code with it, and we'll be using a different function called split. So we have the game display. We have to access it through the game display, and here we'll put the image. And since we already know the size of the image, we just need the position of the image. So that's just going to be the player's X value, player's Y value. And we don't need to define a color because it's an image. Okay, we should be able to run this, and yeah, now we have an image. So you can, I hope that makes the game a little bit more personalized. So yeah, feel free to ask Todd and I any questions you have about making this game, or what you can do after you learn this, and like how you can extend the game.
How would you make it to where you can have the doctor shoot lasers or something at the virus to destroy it instead of it always hitting you?
Oh, that's a good question. So what you could do is you can create another set of variables where you create a new rectangle. So we would just create a new rectangle, like where that would represent the laser, and we would track the width, the height, and then the X and the Y. And whenever you click it, it would start, the rectangle would start at the like the center of the doctor. Like that would be its position, but then it would just move up in the same like X, the same X as the start, but then it would I guess it would decrement because you would be starting at the bottom of the screen. I mean, the top of the screen. This is the bottom of the screen, but it's this is going to be 0 pixels up here, and this is going to be 600 pixels at the bottom. So you start from the bottom and you increment it, and then you check it when it hit. You check if it hits the corona image with the same collision logic. So, and you can do that. You can get the key press with key down, and then I think there's pygame.space or something. I think that's one of the variables. So you can do like key event equals like if key event dot key, and then you can pick a key. You can look at the pygame.documentation and pick what key you want to represent shooting.
Okay, cool. Thank you.
No problem. I think Todd also he used Pygame, and he used it, and he made a tower defense game, and he had shooting in it. So I guess, Todd, do you want to talk a little bit about it, or?
It doesn't really work on the Mac, so I don't really want to show it. Yeah, sorry about that. Ajay wanted me to show this game I made, but this doesn't really work very well right now. Yes, Hello World has checked it out. And, I guess I could share the link if you guys are interested. All right, so yeah, if you want to check it out, there's a YouTube link, and I just made a game a while back, and I think like Pygame, like it's a really good way like to learn like object-oriented programming as a beginner, super easy. So this is what I did to actually like start learning Python, and it got like very complicated, but it's a pretty neat game. Yeah, so you guys can check it out if you want to. Any other questions?
I'll see if I can show you something I made in Pygame. One second.
So if you wanted to add a score That probably wouldn't be too hard, right, Ajay?
Yeah.
You could
So-
probably like add it right. Do you think you could add it right now? Do you know the one for displaying like a number?
I don't know it off the top of my head, but I can point you like, and give you a good resource to learn how to do scores. Or where I learned how to do it when I made my programming thing. So I'll just, this was a good resource. This is actually what this tutorial is based.
Well, just to answer your question, like the way you do it is you would add some counter. You say like counter equals 0, and then maybe every time the enemy box hits the ground, you say like counter plus. You add 1 to counter, right? And then there's a function in Pygame. Yeah, we don't really remember it, but it's not actually very difficult to implement that part. To display like text or a number, and you can just display it on the screen. So it's actually, that part's pretty simple and no problem.
Yeah, I can just share something I made in Pygame if you're curious. I think it'll work.
Do you have a question?
Yeah, actually, Todd, I was just asking that, do you have a GitHub repository of your game so that I can just look at the new code and probably do some improvements or other thing if you want, like if you wish that I could change your code.
Yeah, I can share it, but I need to warn you. It's like the code is pretty disgusting. I mean, I was kind of new to Python, so I mean, I can put my GitHub on there, but like I don't know how helpful that'll be. Let's see.
Do you guys see this, or?
Yeah.
This is kind of a simple simulation I made. So there's a simulation called the SIR, so susceptible, infected, and recovered simulation. Basically, you use like a bunch of like agents, and if an infected agent touches a susceptible agent, then it gets infected, and then after a certain amount of time, it recovers. I guess it's easier to see. So here we kind of have where it started. And then I guess it's spreading. And it just keeps track of the number. This is kind of how you would do the score. You can keep track. I have an array, and I keep track of the count. And maybe for that game, a good way to keep track of score would be how many squares you dodge. So each time the square would come to the bottom of the screen, you can increment out. Yeah.
Do you still have a question, or are you good? You got your hand raised.
So, there's a lot of things you can do.
turn it on.
Oh, sorry.
All right, yeah, no problem.
There's a lot of things you can do with Pygame. So.
Joy, are you there?
Oh yeah, what's up?
I was just checking. I mean,
Yeah.
it seems like we're mostly done.
Okay, yeah. Do you want me to stop the live stream then, or?